Moving at 130 kilometers along a straight horizontal road, a driver sees a trap 70 meters away. His reaction time is 1 second, so let's just draw that. There's our little car. 70 meters away, there is a trap. But it's going to take him 1 second to react. We don't know how far that is, but we do know it takes 1 second. The car then decelerates, so we've got an acceleration of negative 6 meters per second squared. First, we have to convert 130 kilometers per hour into meters per second. That shouldn't be difficult. It's 130 kilometers per 1 hour. I have no difficulty converting kilometers into meters, which is 130,000 meters, divided by 1 hour is 3,600 seconds. Pop that onto my calculator and I get 36,11 meters per second. So that's the speed over here, 36,11 meters per second. What distance is covered just during the reaction time? Now, when we've got constant velocity, we are allowed to use the triangle that says displacement is equal to velocity divided by time. So if I'm looking for the distance traveled, distance is equal to velocity divided by time. I've got a velocity of 36,11, and I know that that happened for 1 second. So the distance that was covered during the reaction time is 36,11 meters. Meaning that, 6 is not looking great, anyway, meaning that what's left over to cover is going to be 33,89 meters. In other words, it's the 70 meters minus the 36,11. That distance, 33,89, is going to be decelerated at negative 6 meters per second squared. And I am going to have an initial velocity of 36,11 because for this whole trip over here, 36,11 meters per second is the velocity. So let's take a look at what they ask now. How long does it take to reach the speed trap? So I am going to work out the final velocity when I've got this information, and this information. So let's try that. So v squared is equal to u squared plus 2as. I'm just going to go on a little pause here. I've got a distance, I've got an acceleration, and I've got an initial velocity, and I'm interested in the time. That's what they want. If I put that in, s is equal to ut plus a half at squared. What happens is I land up with a quadratic function because u is not 0. If u is 0, then this whole term just disappears. But u is not 0, it's 36,11. So I'm going to have a number in there multiplied by t, and then a number in here multiplied by t squared, and that turns into a quadratic function, which is revolting to factorize. I suppose you can use the quadratic equation, but I'm going to rather first find my final velocity using a different equation of motion. So I substitute in my values 36,11 plus 2 times negative 6 because I'm slowing down, and my distance is 33,89. Didn't quite fit, but anyway. And I find my final velocity, don't forget to square root, is 29,95 meters per second. That is the speed at which I cross the speed trap. So I've now got an initial velocity, a final velocity, an acceleration, and a distance, and I can pretty much use any other equation of motion that I choose, and I'm going to go with a nice easy one. V is equal to u plus at, and I'm going to say I know my final velocity is 29,95. I know my initial velocity was 36,11. I know that I slowed down at 6 meters per second squared. What is my time? And my time turns out to be equal to 1,03 seconds. But the question was, how long did it take to reach the speed trap? That was my starting time. I had 1 second. This portion of the journey over here takes 1,03 seconds. So the total time is equal to 1 plus 1,03, and that's equal to 2,03 seconds. Then finally they say what distance is required to stop the car while applying the brakes. That's a whole lot easier to calculate because we now have a final velocity. My final velocity would be 0. And they want to know a distance, so if I go v squared equals u squared plus 2as, and I substitute all of that information in, I will land up with 0 is equal to my starting velocity, 36,11. Don't forget to square it. Plus 2, negative 6, because I'm slowing down, over what distance? And when I rearrange that, my distance is 108,66 meters. A train is traveling along a straight track at 10 meters per second, accelerates uniformly given for 30 seconds. So let's write out our stuff and get our information clearly down. So initial velocity 10 meters per second, acceleration 0,25 meters per second squared, time 30 seconds, final velocity is what I'm looking for. So the best equation to use is simply v is equal to u plus at. Substitute in the information. And I land up with 17,5 meters per second. How far did the train travel in that time? Now I'm looking for the distance, so I look for an equation that does not have v in it because I don't want to carry my mistake. If I did and I did it correctly, I'd get my marks, but I don't want to. So that's equal to 10, 30, a half, 0,25, and 30 squared. And I land up with a distance of 412,5 meters. Simple substitution. A brick falls off a scaffold at a height of 80 meters above the ground. Calculate the magnitude of its velocity after falling for 2 seconds. What's very important is that if we've got falling, we have got an acceleration of 9,8 meters per second squared downwards. So once you've got that information, it's not awfully difficult. I've got an acceleration. I've got a time. If it falls, it started at 0. And we now want the final velocity. That's what they're asking for. We don't know 80 meters. It's not a distance that we've been given. We know that it was 80 meters above the ground. We don't know what the distance was after 2 seconds. So substitute in v is equal to u plus at. I don't know the velocity, sorry, is equal to 0 plus 9,8 down, and I've taken now down to be positive, and my time is 2 seconds, and I land up with 19,6 meters per second, and it's downwards. I know that because it's also positive. What was the time taken to fall to the ground? If I'm dealing with the ground, I am now considering this full distance of 80 meters, not the 2 seconds, not this speed over here. I now need to consider the full 80 meters. So my distance is equal to 80 meters. My acceleration is equal, and that's down. My acceleration is 9,8 meters per second squared, down. I've got an initial velocity still of 0 meters per second, and I'm interested in time. So I substitute in s is equal to ut plus a half at squared. And the good news is this term disappears because of the 0 in the u. So s is equal to a half, we know s is 80, a half, acceleration 9,8, and I'm left with t squared, and t turns out to be, when I square root it, 4,04 seconds. And finally, what is the velocity when it hits the ground? So now I'm going to look for velocity. Ideally, I don't want to use my time, so I'm going to say v squared equals u squared plus 2as. Final velocity is what I'm looking for. Initial velocity 0, squared, doesn't matter whether it's squared, it's 0. 2, 9,8 down, and 80 meters to come down. And I find that my final velocity turns out to be equal to 39,6 meters per second. A ball is thrown vertically upwards. Again, we've got this ball in the air situation, and therefore my acceleration is going to be 9,8 meters per second squared down. And it is thrown up at a velocity of 30 meters per second. So it goes up, given 30, and then the ball goes up, stops, and will come back down again. These two parts of the journey, the up journey and the down journey, are mirror images of one another. So this will come down at 30 meters per second down. Whatever the time is to go up will be the time to come down. They are exact mirror images. Why? Because they have the identical acceleration as long as that ball is in free fall. What is the maximum height reached? At the maximum height, u is equal to 0 meters per second. So let us substitute in all of our information, and we have got v squared equals u squared plus 2as. My final velocity is 0, my initial velocity 30, plus 2, and I've taken plus 30 to be up, so I'm going to go negative 9,8, and my distance is what I'm looking for, and the distance comes to be 45,92 meters, and that would be upwards. And this part of the journey is 45,92. This part of the journey is 45,92. The next one is how long does it take to reach this height? V is equal to u plus at. And I say I've got a final velocity of 0, an initial velocity of 30, plus negative 9,8 time. And my time turns out to be 3,06 seconds. So it takes 3,06 seconds to get up. It must take 3,06 seconds to come down. And then the last question, what is the velocity as it reaches the thrower's hand again? Because of the fact that it's a mirror image, you get exactly that. But you could have said, I know it starts at 0. Sorry, that was my final velocity at the top of the journey, wasn't it? I know that it starts at 0 for the downward journey. It's in the air for 3,06 seconds. It's accelerating at that rate downwards. And I would have come up with 30 down again. An aeroplane accelerates along the runway from rest, and its acceleration is 8 meters per second squared. We're not in free fall now. We're on a runway. For 12 seconds during takeoff, calculate the takeoff speed. It's from rest, so initial velocity is 0 meters per second. V is equal to u plus at. 0 plus 8 times 12. My final velocity is 96 meters per second. What is the minimum length of runway? So now I'm interested in S. S is equal to ut plus a half at squared. And that is equal to 0 because there's no initial velocity. Plus a half 8, 12 squared is equal to 576 meters.